Quinn tosses a ball to his dog, Archer. Quinn throws the ball at a velocity of 12 meters per second at an angle of 60 degrees. He releases it from a height of 1.3 meters above the ground. If Archer is standing 8 meters away from Quinn, at what height does Archer need to have his snout in order to catch the ball? Is it likely that Archer could catch it, or will he most likely miss it? Air resistance on the ball is negligible and can be ignored. This problem will focus on using kinematic equations, more specifically projectile motion, and also just generally getting comfortable with using vectors. Let's start by drawing a picture. Here's the ball being thrown, and here's its trajectory to this dog. Now keep in mind that we don't actually know where this peak is. We don't know if it's on its way down or on its way up when it reaches the dog. There's a lot we don't know. That's its starting height, that's its ending height. This is just a general sketch to give us an idea, but we shouldn't assume that just because my sketch shows, for example, that the peak height seems to be right in the middle, that that's actually true. This is just a sketch. Let's also draw in our XY axes so we know where the origin is. It doesn't matter where we choose to be the origin, we just have to be consistent. And I think that my preference is to make it at the ball's initial position horizontally and then on the ground, speaking vertically. There's our Y-axis, there's our X-axis. Now let's start filling in what variables we actually know. We need to be careful because that amount of 12 meters per second is not in just the X or just the Y direction, but when we're dealing with vectors, we have to keep everything separated in one direction. So here just the X direction, here just our Y direction information. And then you'll notice I put time in the middle because time is not a vector, it's a scalar, and so it can apply with either the X or the Y. It's always true. So let's fill some things in. We know that the initial point that we start at horizontally, that the ball starts at, is 0 because we decided on the location of our origin. And we also know that its initial starting height is that 1.3 meters. We know that the final X position is going to be 8 meters when the ball reaches the dog. We don't know the final Y position. That's what we're trying to determine. We're trying to determine the height of the ball eventually. So this is what we really want to solve for. Then as far as the initial velocities, this is where we need to be careful. We cannot plug in that the initial velocities are 12 meters per second because that again is at an angle of 60 degrees. We need to break that 12 meters per second at 60 degrees into its X and Y components. So V naught X is going to be 12 cosine 60, and V naught Y is going to be 12 sine 60. Vx and Vy, we're going to leave for right now, not known. Ax and Ay we should know because this is a projectile motion problem in which we can ignore air resistance, we're told to. So we know that in the horizontal direction there is nothing pushing or pulling on the ball, nothing causing acceleration. So our horizontal acceleration is 0. Then in the y direction we know that our acceleration is negative g, aka negative 9.81 meters per second squared. We do not know time. Now I've gone ahead and filled in what 12 cosine 60 and 12 sine 60 are equal to. So 12 times the cosine of 60 degrees is 6 meters per second, and 12 times the sine of 60 degrees is 10.39 meters per second. And this is going to help us then determine what v sub x is as well. If v naught x, the initial velocity in the x direction, is 6 meters per second, and there's no acceleration in that x direction, that means that Vx is also 6 meters per second. This means that in the horizontal direction, the ball just keeps traveling at that same speed of 6 meters per second. In the y direction, though, we don't know this. This is not information that we know automatically. We also, as I said, do not know time. We now have enough that we can start working with things and trying to solve for the variable that we want, this final height. Let's take a look at our kinematic equations for projectile motion. We know that the variable that we want to solve for is this y, this final height. And we can see it in this equation here, right here. And then we also see it here in this equation. If we look at these equations and we look to see, do we have the necessary information that we could solve for y, either here or here, we see that we don't. In this first equation, we'd need to know time, and we don't know time. We don't know how long that ball is in the air. If we were to use this equation, we'd need to know the final velocity of the ball in the y direction, which is also not something that we know. So as far as y direction information, we're kind of stuck. But there's a reason that we also have all of this information that we can evaluate. In the horizontal direction, because there's no acceleration, we only have one equation, and it's this simple one. And in this case, we know enough that we can solve for time. We know its initial position is 0, its final position is 8 meters, and we know its initial speed is 6 meters per second. That's enough information that we can then solve for time. So let's fill that in, and we have 8 equals 0 plus 6 times time, which we then get that the time the ball is in the air when it travels 8 meters is 1.33 seconds. Because time is a scalar, that means that this is true not just in the x direction, but in the y direction. So we can now take this result and plug it in here into our kinematic equation for time in the y direction. So we can solve for that height. So let's plug that in and solve. We get y naught we know is 1.3 meters. V naught y is 10.39 meters per second. And that time we just determined is 1.33 seconds. And then we have 1/2 times, now remember this is negative 9.81. And then we have that time that we just determined squared. This gives us a result of 6.44 meters. Now let's go back to our original write-up of the problem and consider this answer and what it means. So we were asked to find the height at which Archer needs to have his snout in order to catch the ball, given the distance he was away from Quinn and given the velocity that Quinn threw the ball at. We've determined that that's 6.44 meters. And so the question is it likely that Archer could catch it, or will he most likely miss it? So let's convert meters into feet. This gives us, this is approximately 21 feet. So, is it likely that Archer could catch it? No, it's not. Is it likely a dog could jump 21 feet into the air? No, it's not. So this tells us that in this problem, our original sketch, where the ball went directly to the dog, was inaccurate. Given those initial conditions that Quinn threw the ball at, and given their distance away, the ball has gone over Archer's head, and even if he jumped as high as he could, a dog is not going to be able to jump 20 feet into the air. So this tells us, nope, he's going to miss it. And we have our answer.